Okay, good afternoon to all. So in today's class, in our first session, we were solving one problem based on single cylinder 4-stroke engine, and we were at this juncture in the classroom. So we have drawn this diagram, the turning moment diagram, and also we have actually derived one relation between y and x. We have considered this peak height as y and this valley depth as x, and we have derived y equal to 3x. And also in the question is given that the power is 18.4 into 10 power 3, that is 18.4 kilowatt, and we have obtained work done per cycle, which is the work done per second upon the number of cycles per second. And this work done, we have actually, it is equal to this power, which is 18,400, and this cycle is the number of cycles. And as you can see that in 0 to 4 pi, we are actually getting two effective cycles. As we have ignored the suction stroke as well as the exhaust stroke, so we are only getting two cycles. So this 300 by 2 into 60 in seconds. So we are obtaining this as the work done per cycle. So we have reached up till this part, and we are going to solve it further. So as again, I will repeat it once again, that our main objective is to find this particular area of the triangle, which is above the mean torque line, right? And that is actually responsible to give us the fluctuation in the energy. Okay, for a non-sinusoidal plot, that is very important for us. So let us simplify this. So let us first find out that what we have already obtained work done is this amount. So the net work done is basically pi y minus x by 2. How it is this area, which is pi by 2 y minus x, this triangle, expansion stroke triangle minus the compression stroke triangle. So that is equal to 7360. So from here we obtain y minus x equal to, this will be 46, then it is 87.9. So y is equal to 3x, so we can obtain the value of x as, so it is 3, it is 3.95. So the value of x and y we have obtained. So as we have obtained the value of x and y, let's find out this value of Tm. So this mean torque is equal to the work done per cycle, which is 7360 divided by 4 pi. Please note it is based on the stroke engine. Whether if had that been a 2-stroke engine, we would have placed 2 pi, and as it is a 4-stroke engine, so we are placing it as 4 pi. So if we solve it, we get 586 approximately Newton meter. Okay. Now our main concentration is this triangle, which is above the mean torque line. Okay, this we have already discussed in the class. So again you see this is the area, that is, this is pi into y by 2 minus pi into x by 2, it is the work done per cycle. So this is the first part, and let us find out this particular height y, as well as we have already obtained y. So let's find out this particular height. Okay, because we need to know the area above the mean torque line. So we need to find out this particular height above the mean torque line. So this can be done as this triangle, the upper triangle and the entire triangle are similar triangles, and as they are similar triangles by angle criteria, so we can write that this base we require. So let us write down base of the shaded triangle divided by this base, which is pi, is equal to this length above the mean torque line, which is basically y we have obtained as. So let us find out the value of y also. Y is equal to 3x. So if you multiply 3 into this value, this will be around 7031.85. Okay, so base of shaded triangle upon pi will be equal to this upon total y. So this is equal to basically 7031.85 minus 586 divided by the total y, which is 7031.85. Okay, and if we simplify this, we obtain the value of the base, this base here to there. This base comes out to be as this value as 2.878. Why we need this base? Because we need to find out this area of this triangle, which is above the mean torque line, and that is responsible for delta E, which is the maximum fluctuation of energy. So we have obtained this base, which is 2.878 units. So area of this triangle, area of the triangle above the dot line TL is equal to half into base into height. So half into base is 2.878 and height is basically this height, which is total y minus this Tm. So that means it is 7031.85 minus 586, which is 6445.85. This is the area, or you can say delta E. Simply we can say it as delta E. So if you solve, we get around, the value comes out to be as, you can try it yourself, it is 9076.68 Newton meter. And this is, so we have obtained delta E. We know that this delta E is also equal to I omega square into Ks. Okay, we have to find the value of I as per the question. So I can be found out. So let's keep I as it is. Omega is 2 pi n. So in the question we have seen that the value of n that we have used is around, let me confirm it, n we have used as 300. It is 300 upon 60 I omega square, and this Ks value is, the permissible limit is plus minus 2%. So that means the total content is 4% or 0.04, and that is equal to this value delta E, which we have obtained as 9076.68. Okay, and to be very precise, this value I will come out to be, on solving, if we solve it, this value will come out to be as around, it is 235.22, which is the moment of inertia, and unit you know it is kg meter square. Please note all the units over here are in SI. So once we have obtained I, we can find the value of mass. Our objective is to find the mass of the flywheel, and you know that the flywheel is basically is like a disc. So the moment of inertia will follow the equation, that is mr square by 2 for a disc. So m is to be found out. R we have already given as 1.5, so it is 1.5 upon 2, that is equal to this value 235.22. So on solving, we get the value of the mass of the flywheel as 418.17 kilograms. So this is the solution of the question that we were doing in the class, in today's class. Okay, and again I am telling that our main objective is to find the area above the mean torque line for a non-sinusoidal curve. Had that been a sinusoidal curve, we would have found out the entire area, and we would have selected at which section we are getting the maximum energy and in which section we are getting the minimum energy, and the difference would have given us delta E. But here in this case, we are only concentrated, or we are interested to find out the area above the mean torque. Okay, so thank you.